Okay, so welcome back to another video. So here we'd like to solve a non-homogeneous initial value problems with differential equations exercise. We want to find a general solution for y triple prime minus phi times y double prime minus y prime plus phi times y is equal to 29 times sine of 2x plus 10x, subtract 63 times e to the negative 2x. And we're also given three initial conditions. We have that y of 0 is equal to 24 divided by 5, y prime of 0 is equal to 1, and y double prime of 0 is equal to 57 over 5. So this is actually not that bad of a problem, but for one, it might look a little scary due to the fact that we have an equation of the third order. And if you're taught in the introduction to differential equations course, usually a lot of it deals with like the second order when dealing with homogeneous or non-homogeneous. Non-homogeneous being you have a differential equation is set to equal to a function, and then homogeneous is such that instead of a function, the whole thing is set to equal to 0. But when dealing with non-homogeneous equations such as this, we would actually need to use a method known as the undetermined coefficients method. What that implies is that to find that general solution, we actually need to find the homogeneous solution first, that is set this equal to 0 first, and then solve from there, and then add this with the particular solution we're going to solve from here. So in other words, this is more of like a guess and check form such that we have something of a nice form of the function on the right-hand side and solving from there. Then, of course, just plug in the initial value conditions, and then we get the general solution as we want to achieve. So it's actually not that exactly scary, or people might think it might pose as a challenge due to the fact that we have a third order equation when usually it's a lot easier when you're dealing with second order. But all that work and process is basically just everything is you're taught from the introduction to differential equations standpoint. So nothing to be afraid of from there. So with all that said and done, so let's actually now get into it. So first, in the general standpoint of how to find a general solution, we need that y is equal to y times y sub p, p being our particular solution, and then add this with yc. C, I call this the complementary solution, aka we want to find the homogeneous equation for that. So this is the general solution that we need to solve. So let's actually start by solving for the complementary equation, the homogeneous equation, in other words. So starting off, so we have the differential equations on the left-hand side, so that stays the same. So y triple prime minus phi times y double prime minus y prime, and then plus 5y. Now set this equal to 0. Then as you're taught in the class, you want to find some guess and check form such that it fits the following, set it equal to 0, but you can actually now apply the characteristic equation and substitute this for r cubed minus phi times r squared minus r, and then plus 5. Set this equal to 0, and then this can be easily factorable. So we have three different products for the binomial products. So now we have r minus 1, then times r plus 1, and then multiply with r subtract 5, set this equal to 0. So we actually know that we have our three different constants. We have that r sub 1 is equal to 1, r sub 2 is equal to negative 1, and then r sub 3 is equal to positive 5. So with this, we can actually now come to the general solution for our complementary function and say that y sub c of x is equal to just some constant c sub 1 times e to the power x. Add this with c sub 2, then times e to the negative x, and then add this with c sub 3, then times e to the 5x. So now that's out of the way, let me actually box this just to say that this is our complementary / homogeneous equation that we solve for. That's actually going to come in handy later as we put together in order to get the general solution that we would need to achieve for. So with this now, let's actually now solve for the particular solution. So this is where the undetermined coefficients method will need to come in handy and / utilize. So for now, I'll call f of x our right-hand side. So I'm just writing the exact same thing. So f of x is equal to 29 times sine of 2x. Then we add this with 10x, and then subtract 63e, then to the power negative 2x. When dealing with situations with undetermined coefficients with our function, we need something of a nice form such that it actually fits the criteria of our function on the right side. So we have a constant with a trigonometric function. Keep this in mind. If you have a sine of 2x and you're going for the guess and check form of when you're dealing with this stuff, you shouldn't just write just sine of x. You also have to deal with more trigonometric functions, such as you write it as a linear combination of sine of whatever input, add this with cosine of whatever input. So in this case, we have a nice form that we want to use. So some constant a plus some constant b. So, well, in other words, a times sine of 2x with that input, and then plus b times cosine of 2x. And so when that's down, so we have 10x, so we have some form of a linear function or a polynomial. So I can actually write this as a linear function cx plus d, for example. And then we have something of an exponential function 63 e to the negative 2x. Keep that input the same for the exponent. So e times, or capital E, I'll put it that way. Capital E times lowercase e to the negative 2x. So with that, now let's actually just write that as our particular solution form. So ypx, here we'll say that this is a times sine of 2x, add this with b times cosine of 2x, add this with cx plus d coming from our polynomial over here, and then subtract capital E, or rather, this is going to be a plus, it's a linear combination, everything is all in plus in that nice form. So capital E and then times lowercase e to the negative 2x. With this in mind, so because we have the left-hand side for y triple prime and then double prime and y prime and y, so what we have to do is we have to take our particular solution of that form and differentiate for 3 different derivatives. So we need to differentiate for y prime, y double prime, and y triple prime. So that's actually the fairly easy step there, as most of you guys know how to do your derivatives. So let's start off with y prime. So y sub p prime, so take the derivative, this is very simple. So what we'll have is that we'll have 2 times a multiplied with cosine of 2x. Then I have subtract 2b, then that'll be sine of 2x. Add this with c, and then now this will be subtract 2 times capital E and then e to the negative 2x. Okay, so now we have that. Now let's actually differentiate a second time, so we get y double prime for the particular solution. Doing so, that'll yield us negative 4a cosine, or rather sine. Now that we have the negative here and differentiate cosine, so negative 4 times a times sine of 2x, then subtract 4 times b, this will be cosine of 2x, and then add this with 4 times capital E and then e to the negative 2x. Then we do this again one more time, so y triple prime. So for a particular, so now we'll have negative 8 times a cosine of 2x, add this with 8 times b sine of 2x, and then subtract 8 times capital E and then times e to the negative 2x. Okay, so with all this, now let me write a little note and say we're going to plug this back into our original equation. So plugging all this back into the original, so that's actually going to be a long one. So let me actually just cut to the next clip so we have everything substituted as we needed. Okay, so now that everything is substituted in, so this is our y triple prime, and then I distribute 5 to the y double prime, so that's what it comes down to over here. Then we have minus y prime here, and then I did the same thing, distributed 5 to the yp over here, so this is what it comes down to. So we put everything together, so now we have that the following sum for all the linear combinations of everything we just substitute in. We're now going to have that this will yield negative 10a cosine of 2x, add this with 10 times b of sine of 2x, add this with 25a multiply with sine of 2x plus 25b cosine of 2x, and then now subtract 21e capital E to the, and then multiply with e to the negative 2x, then subtract c, add this with 5 times d, and then add this with 5 times c times x. And of course, all this is set to equal to the right-hand side of the equation. So now what I'll do here is I'll actually get rid of this side of the board, and then we'll actually make use of the room to actually now find what the coefficients of a, b, c, and d are. Okay, so it's straightforward to see that all we have to do is when we find our coefficients that we just have to set everything from the left-hand side to the right-hand side, and then everything forms in a nice systems of equations. So applying from here, so that means I have 5 different equations that we have to set for the equating all that. So for one, we have that this is going to be 25a, add this with 10b is equal to 29. So that's just everything from the sine of 2x, everything coincides with that. Next I have is a negative 10a, add this with 25b, set this equal to 0. There's nothing for the cosine of 2x, so that actually makes things a little bit easier. Another one is negative 21 times e, let this equals negative 63 from that exponential. Next I have a 5 times c, set this equal to 10, that's just the linear function for 10x. And then one more I have is negative c plus 5d is equal to 0, so no constants on the right hand side. Thank you. So it makes things a little bit easier, and for one we see that this makes things nice that we have e is equal to 3, c is equal to 2. And so if I just plug in the 2 back over here and solve for that, that means I have that d is equal to 2 divided by 5. So we're actually just left with these two equations to solve. So what I'm going to do here, we'll set this as a system of equation for 1. So I'll actually multiply a 2 for the first line of the equation and multiply a 5 for the second line. So now that'll yield us 50a. Add this with 20b is equal to 58. And then for the second equation, the second line equation, I have negative 50a. Add this with 125b, set this equal to 0. So we have that the 50a's the cancel out. So now this will just yield us 145b is equal to 58. Then divide that by both sides. So now I have that b is equal to just 58 over 145. That will reduce to 2 divided by 5. And so if I just put this back in, solve for a, that's simple to there to see that this is a is going to just equal 1. So that means we already solved for our 5 unknown coefficients from the particular side of the equation, just like that. So now all we have to do is just substitute everything back in. And then that's how we get our particular solution. So therefore yield us that the y particular solution of x is going to yield us sine of 2x. Add this with 2 divided by 5 cosine of 2x plus 2x. And then add this with 2 divided by 5. And then plus 3 times e to the negative 2x. So therefore, this is our particular solution. And what I'm going to do now is I'll erase all this, write down our general solution that we have, and then we'll get to now solving with the initial conditions. Okay, so this is adding together our homogeneous solution, which is the C1ex, C2, and C3, the linear combination from there. Add this with our particular solution that we just solved over here. So now all that's left is to find now the final general solution using our initial value conditions given. So we have y0 equals 24 over 5, y prime of 0 is equal to 1, and y double prime of 0 is equal to 57 over 5. So that's actually an easy method from there, but for more the tedious work, since we have 3 different conditions and it's a lot more to add into it, but let's actually start things slow and take things one at a time. So now what I have to do now is let's actually plug 0 to our general solution over here. So I have y of 0, straightforward, so that means I have sine of 2 times 0, add this with 2 divided by 5, cosine of 2 times 0, add this with 2 times 0, add this with 2 divided by 5, plus 3, then times e to the negative 2 times 0, add this with c1e0 plus c2e to the negative 0, and then plus c3 times e to the power 5 times 0. And of course, all this is set to equal to 24 divided by 5. So actually everything that it comes to reduce down to, so let's see, I have 0, then that'll be 2 over 5, add this with 0, plus 2 over 5 again, then add this with 3, and then all that's left is just C1, C2, C3. So C1 plus C2 plus C3. So therefore, that'll yield us, say that that's the same thing as C1 plus C2 plus C3. Then if I want to, I'll subtract the sum of these together. This will come down to 19 over 5. I'll subtract that to both sides, and so subtract that with the 24 over 5, and so that'll yield us with just 1. Okay. So that's nice. So now let's actually move on to the first derivative. So let me actually first underline this. So now moving on, we have y prime of 0. If I plug this in, so the derivative over here, this is actually just going to be 2 times cosine and then of 2x. We'll substitute that for 0. Then now subtract. So this is 2 divided by 5, and then that will be sine, or rather, now that's going to be 4 since I have to multiply the 2. So instead, 4 divided by 5 and then times sine of 2 times 0, then that's just going to go away, and then that's going to go away. Well, actually, now this is actually going to be plus 2, and then over here is going to be minus. So let's see, I have 6, since this is going to be e to the negative 2, 0, so minus 6 over here. So I'm actually just write this out in full. Last is left is just to take the derivative of the C1, C2, and C3. So doing so yield us now is going to be plus C1, and then multiply with e to the power 0, subtract c2 e to the negative and 0, and then add this with 5 times c3, then e to the power 5 times 0. So what that'll yield us now is that I have a 2, and then plus 2 is 2, and plus 4, sorry, and then minus 6, so that's going to be a negative 2. And then everything else will just disappear since sine of 0 is just 0. So now that'll yield us with c1 plus c2 plus 5 times c3 is, no, it's actually supposed to be a minus from over here. And then minus 2, And if I actually just solve that for on its own, we said that that's equal to 1, then I'll just add the 2. So therefore, that's just going to equal 3. So now that's our second, rather the first derivative that we solve for in terms of the coefficient. So now let's actually move on to the third one, the y double prime of 0. So now y double prime of 0. So that's the last thing we have, y double prime of 0. Then that means if I just do this, so that will yield us, this is going to be negative 4, then sine of 2 times 0. And then over here, this is going to be minus 8 divided by 5, and then cosine of 0, 2 times 0 rather, but that's still equal to 0 either way. That's going to disappear. And then now this is going to be add this with plus 12 times e to the derivative of negative 2 times 0. And then last is our C1, C2, C3. So over here, that's going to be C1 and then e to the power 0. Then now next is we have plus C2 and then e to the negative 0. And then last is now we have plus 25 and then C3 of e to the power 5 and then times 0. All this yielding is that will get us C1 plus C2 plus 25 C3 and then plus 52 over 5 when you add up everything together. So we have 12 and then minus 8 over 5, and so that will yield us 52 over 5. Subtract that with both sides to the 57 over 5, and so that'll just yield us with equals to 1. So now all that's left now, let's actually put this together as a systems of equations. So everything I have underlined in black, so I have C1 plus C2 plus C3 is equal to 1. Then C1 subtract C2 plus 5 times C3 is equal to 3. And then C1 plus C2, add this with 25 C3 is equal to 1. So this looks like we have 3 different combinations, and we can't exactly do that whole equate things because everything is in terms of just constants. So it makes things a little bit challenging because everything is in terms of a constant. So here's what I'm actually going to do. This is a little bit of a trick when you're dealing with systems of equations. What I'm going to do is I'm actually going to take one pair of equations such that when I add them together, it actually eliminates a term. Then do the same thing for the other pair, and then once I actually do those, take those 2 pairs that we actually put together as one and solve for the one constant, and then we'll be able to solve for the rest. So what I'll do is I'll take the first equation, C1 plus C2 plus C3 equals 1, and then the second line over here, add that together. So put this over here like this. So if I add everything together, so I have that 2C1 plus 6C3 is equal to 4. In other words, I can just divide the 2 to both sides. So C1 plus 3 times C3 is equal to 2. Okay, so that's the first one. So now the second one is, now I'll take this pair over here. So that means now this is going to be 2C1 and then add this with 30C3 equals 4. And so now just do the division, divide by 2 both sides. So I have that C1 plus 15C3 is equal to 2. Then I'll just take these 2 together, just add them up. So now I have, so put this together, C1 plus 3C3 equals 2. Then C1 plus 15C3 is equal to 2. And then what I'll do is to eliminate one of the terms, I'll multiply a negative 1 to the first line of the equation. So that means I have negative C1 minus 3C3 equals negative 2. C1 plus 15C3 is equal to 2. And so we have that the C1s cancel, but what's nice is that we have that this is equal to 0, and so therefore this just leads to the conclusion that C3 is equal to 0. Okay, so that narrows that down, and so that makes everything easier for here. So go back to originally, so we have C3 is equal to 0 here, so that means I have that now that we have C1 is equal to just 2, and we have that C2 indeed, lastly, and then we have everything solved together is negative 1. So we have solved for our 3 unknown coefficients yet again for a second time, just like that. And so now we're pretty much actually just done. So we just put everything back together. So therefore, our final solution for the general solution of all the coefficients solved for is that y of x is equal to sine of 2x. Add this with 2 divided by 5 cosine of 2x plus 2x plus 2 over 5, then plus 3 times e to the negative 2x. Now add everything with the coefficients we just solved for. So C1, so that's going to be plus 2 times e to the power x, and then minus e to the negative x, and then plug in 0, which is 0. And so therefore, this actually completes our general solution to solve for the third order non-homogeneous equation / initial problem, just like that. a monstrous differential equation if I say so for myself, but it's just actually the easy stuff, but it's a lot of tedious work just like that. So yeah, that's pretty cool if you ask me.